Okay, let's try this. We've got someone who's in quarantine, so I said I'm going to start recording my lectures. So this is that. That's what I'm trying to do there. Okay, so today we're going to do 2.2, and that's going to be the end of the first block. So for the test next week, that's going to cover chapter 1 through section 2.2. On Monday, we're going to meet in 12:20, and we're going to do a little lab. We're going to do some stuff with Excel. There's lots of computer programs that you can use to do math. I thought Excel would be useful because for you guys, I think it's useful if you know how to use a spreadsheet. So it's transferable skills, if you like. Okay, so the last thing, so what's chapter 2.2 about? So if you remember, last class I explained the idea of a derivative. And by that I mean the instantaneous rate of change of the function f at x equals a. Let's say f of x. Okay, and that's the same thing as the slope of the tangent line of f of x at x equals a. And we talked a little bit how we would go about finding such a thing. If it was given to you as your formula, you would just do a tiny little interval and do rise over run. If it was given to you as a graph, you would again do rise over run over some interval. And if it's given to you as a graph, you would get your ruler up there and you would draw a tangent line, and then you would figure out a rise over run. Oh, typically. Gets you after a while, doesn't it? Okay, now here's the point of section 2.2. We have a function. Because remember what a function is, okay? All you need for a function is a way to turn an input into an output. Okay, so my input is the point A. My output is, well, what is the rate of change at A? So that's a rule that you can go then proceed to do. So if I give you a function, somehow, given any point, you could go ahead and you can construct what the rate of change is that way, and you could figure out a table really easily. Also, you could figure out a slope, maybe if it's given as a graph or something. And this is a goal for us. Later on, we'll actually figure out formulas. Okay, so let's do some example of turning a graph into a graph. So by that I mean, no, we don't. Pity. Okay. So here is my function. Now let this be f of x. Let's draw a graph of the function f prime of x. Okay, so what kind of function is f of x? It's linear. What's its rate of change? It's constant, right? Because it's just the slope. At any point, you could figure out rise over run, and it'll be the same number. So its derivative is a constant function. Is it positive or negative? Positive. And so since we haven't given any scale, all we would do is pick a point. Let's say it's this point. I'm going to put in a dotted line because I haven't got colored chalk. And there. Ta-da, not so hard. It's hard to come up with numbers because I haven't given you any numbers. Okay, that's okay. Let's do another one. Okay, so what do we know about f prime of x?
It's not constant.
It's not constant. Okay, good. Next, someone say something true about it.
Positive.
It's positive. That's one thing for sure. And something else that you should notice. Is it getting steeper? Which means what? It's going to be increasing. So over here, it's looking pretty flat. So it's going to be pretty low. And it's going to start increasing. It's actually going to, this function actually, the derivative kind of looks like the function itself. We'll see later that this is always true for exponential functions, right? Exponential functions, what is their big giveaway? They've got constant relative change. Constant relative change means that, that its change is kind of proportional to itself. So it's going to be just some fraction of itself. So this is typical of exponential. Let's do something a little bit harder. I'm sorry, since I'm recording, I can only use one board. That's how big my let's say we have a function like this. Oh, so that's f of x. Okay. Okay, so we're just trying to come up. So the idea of these exercises is you're doing like a caricature, right? What do you do in a caricature? You put in the important features and you emphasize those. Okay, so what are some things you can tell me about the derivative? Can anyone tell me what the derivative is at this point, and this point? It's zero. It's not just constant means it's a straight line. Zero means flat. So that's a good start, right? So that means here, here, and here, that the function, that the derivative is flat. Okay, next bit of information.
Parts of it, it's negative.
Okay, so where is it? So if we call these A, B, and C, what can you? When's it going to be negative?
Negative B and then after C.
Right, it's going to be down here and after here. Okay, so where is it at steepest? It's around here. So that's going to correspond to something like this. So maybe it looks something like that between A and B. And then after C, what happens? It goes and it looks kind of steeper here than it does here. So maybe it kind of looks something like that. I don't know. Does that make sense? Okay, what about before A? What does it look like? Yeah, it's positive, and then what's happening to it? So it starts off at some level, say here. We've got to get to A. The only way you can do that is if it's getting less steep, but we look at it and we see, oh, it is getting less steep. So it looks like it doesn't, and then it sort of goes like this maybe. And then finally, what's happening between B and C? It's positive, it's steepest around here maybe, but it's not that steep, right? And then we join it up with the not very artistic, but you got the gist of it. Okay, so let's kind of write down some hints then about how you would actually do a problem like this. So what was the information that I used? Right, so a function increasing means f prime of x is positive. F of x decreasing means f prime of x negative. What else did we use? Fx flat means f prime of x equals 0. So that's the most important thing about the derivative. So this set of facts here. And then the other thing is f of x steep means that f prime of x is what? Well, it's either has big magnitude. Right, because that tells us whether it's steep. It could be steep positive or steep negative, right? But either way, it's going to be big values either way. And fx shallow means f prime of x small magnitude. I'd also add f of x concave up, f prime of x increasing, f of x concave down, f prime of x decreasing. And these are the important things that you should be looking at. So these are the things that you're going to be using to answer things like that. Right? So for example, here, we see here it's concave down, the other thing is decreasing. So when I would grade such a question like this, I would just see, are you obeying these things? And these things should be what you should be doing to answer the question. Let's see if I can do this. Okay. Here's another kind of graphical problem. Draw a function f such that f prime is positive on x between 1 and 3. F prime is negative for x less than 1 and x greater than 3. And the function is 0 at x equals 1 and 3. Okay. So what will we do? We've got to make sure we have 1 and 3 in it. So we want it to be, the derivative to be positive on the interval 1 to 3. What does that mean? It's going to be increasing. It's going to be flat here. So we can put in like a little straight segment here, a little straight segment here, and we've got to increase between there and there. So we just have to put in something like this. Okay. We want it to be decreasing for x less than 1. Okay. So it's going to be decreasing. So going backwards, it's going to be, sorry. It's going to be decreasing, right? So here it's decreasing. There we go. Sorry, I said something weird there, didn't I? I'm sorry. And then it's decreasing afterwards. So that's not really that difficult a problem. Okay, so as long as you remember this, that's all you need to do to answer graphical problems. Let's have a look at a numerical problem. Okay, so I'm going to rub this out. So in a numerical problem, you're given some kind of table of data. So let's say x of x. And typically, if you've given numerical data, you're going to give a numerical answer. So let's try and figure out f of x. Okay. So what does our data look like? Okay, so we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our f of x is 84, 89, 94, 98, 100, 100, 97, 90, 79, 63, 41. Okay, so there's various different questions I could ask about this. So the most basic one is these questions here. When is it increasing, when is it decreasing, and when is it flat? So looking at the data, what does the function start off doing? Increasing. So expect this to be positive. And where do you think it's going to be flat around?
Towards 0 and 1, it'll be flatter.
So I can't understand.
Well, it gets more steep as it goes down.
So yeah, so it's going to be positive. And so when at what values is it going to be flat? Between 4 and 5. So if I was to ask you, for what value of x do you think it's going to be flat? What would you give as an answer? Between 4 and 5, right? What number is between 4 and 5? 4.5, right? So 4.5 would be my best guess for it to be flat. So I would say flat at x equals 4.5, and it's positive for x less than 4.5, and it's negative for x greater than 4.5. I mean, that's the best you can do. The thing with a table is you can't get into real granular, fine details like you can with a formula. Okay, so that's one question I could ask you. Another question I could ask you is, well, give me a table of values for the derivative. What's our rule of thumb? We like to use midpoints, and we like to use intervals as small as possible. So doing from 1 to 9 is going to be easy, right? 94 minus 84 is 10, divided by 2 is 5. Difference is 9, divided by 2, 4.5. 3, 1. Minus 1.5, minus 5. 79 minus 97 is 18, so minus 9. 63 minus 90 is 27, so that's minus 13.5. 28 minus 14. Is that pretty straightforward? So I just use a straight interval. What about the endpoints? We can't have it as a midpoint because there's no value for minus 1. So the best you could do is just to do this interval here. Right? That's a little dicey, right? I don't really think it's 5. I actually think it's going to probably be a little bit bigger than 5, just because of the trend. But, you know, I can't really do anything about it. So 5 is good enough. Meanwhile, over here at the other end, what have we got? Minus 22. Same sort of caveat. So these ones are not as good estimates as these ones, but we can't do anything about that. So that's kind of how we do that. Any questions about that? Is everyone kind of feeling kind of confident that they can do these kind of questions? Cool. Okay. What do I want to do? Let me get rid of this. The other thing you can do is I could give you a formula, and I could ask questions about it. So later on in the class, we'll see that we can actually come up with a formula for this derivative. But at the moment, we're not at that level yet. So what can we do? We can do